Hello HMS modelers, I'm Emily Moe, Senior Hydraulic Engineer with the U.S. Army Corps of Engineers, St. Paul District. In this video, I'll provide an overview of using gridded precipitation methods in a meteorologic model within HEC HMS. The primary benefit of applying gridded precipitation to an HMS model is that the precipitation is then spatially distributed across the watershed, similar to radar, versus a lumped measurement being applied homogeneously across the entire subbasin. Another benefit is that various gridded precipitation products are becoming more widely available. One drawback is that the available grid sets may require conversion from their native format to an HEC DSS record to be usable within HMS. However, conversion tools are available to make most conversions quick and easy. It is important to note that the quality of available data will vary. When selecting a gridded precipitation source, it's recommended to perform spot checks against established precipitation gauges to determine how accurate that source is within your watershed. If applying radar data, a visualization of the radar's coverage may also be useful when considering product quality. There are an increasing number of gridded precipitation products available. This includes both national and regionally developed products, such as from your local National Weather Service river forecast centers. Some of the most popular products are listed here, but additional products may also be available for your watershed. As part of the USACE Core Water Management System, SWIMS efforts, most USACE districts are currently receiving real-time gridded precipitation products to their water management servers. Discussing available data with your local water management staff is highly recommended while scoping new HMS models. So, once you've decided to apply gridded precipitation to your model, how do you convert the raw data to an HEC DSS file? There are a few options available. Select gridded file formats can actually be imported directly into HMS. The Vortex utility is a great tool that can convert several native data formats to HEC DSS, and it allows for additional data manipulation, such as clipping, reprojecting, and more. GaugeInterp is another tool that creates grids by interpolating point source data, such as precipitation gauges. GaugeInterp is particularly useful if gridded products are not available in your region or for historic events that you'll be calibrating to. The GaugeInterp tool is useful for creating precipitation grids from observed gauge data. It takes the point values and creates grids through interpolation, estimating the value at each grid cell by calculating a weighted average of all gauges located within a certain distance. This slide shows two examples of distance being used to determine gauge weight. On the left, more weight was given to the closest gauge with the inverse distance weighting method. On the right, grid cell values were assigned using only the closest gauge as determined by Thiessen polygons. When converting or creating gridded data sets, it's important to name the resulting DSS file so that it is clear where the data came from, the extent of the data, and most importantly, the data type and time. The recommended naming conventions for grid sets is shown here. It's important to note that HMS requires specific C-part names. HMS will not recognize the grid sets unless the C-part name is correct, which we'll discuss next. HMS will not load a grid set if the C-part path name, units, or data type is not correct. The table on this slide contains the correct C-part path names, units, and data type for each grid type in HMS. Once gridded precipitation has been converted to the HEC DSS format and clearly labeled, it is ready to be added to the HMS model. To create a precipitation grid set, head to Components, Create Component, Grid Data. Within the Create a Parameter Grid Data dialog, ensure that precipitation grid sets is selected as the data type, and be sure to name and describe the precipitation data that you are importing. Select Create to add the grid to the Gridded Data Manager. Within the Gridded Data Manager, the gridded DSS record must be linked to the precipitation grid set by navigating to the DSS file and selecting the appropriate path name. Next, the meteorologic model must be configured to use the gridded precipitation by highlighting the meteorologic model name and selecting Gridded Precipitation. The gridded precipitation data must then be linked to that meteorologic model by highlighting Gridded Precipitation and selecting the name of the precipitation grid in the dialog box below. Defining a discretization method is required to run HMS with spatially discrete components such as precipitation grid sets. This allows the HMS model to spatially relate gridded components to subbasin elements, enabling spatial variability within each subbasin versus applying a singular value throughout the entire subbasin. Discretization is defined by subbasin and has 4 methods to choose from. The structured discretization method is a quick and easy approach to discretizing the model, as it applies a standardized grid format at a preset resolution. The unstructured method allows for a user-specified coordinate system and can be easily defined with HEC RAS plan files. File specified allows the user to point directly to an existing HEC HMS grid cell file. Defining a none discretization assumes no variation of variables within the subbasin, resulting in a lumped parameter, non-gridded approach. Once the discretization has been defined, the gridded precipitation can be added to a simulation and the HMS model can be run.